8. In this video, we're going to look at the first section of Unit 1. So we're going to start off here with looking at a Venn diagram, and we're going to use that Venn diagram to talk about what we can do to have a successful quarter. So here's an example of a Venn diagram. All right, so in this case, we have this rectangle, which represents what we're going to call the universal set. And we've got a circle for the instructor and a circle for the student. Let's go back up here and read a little bit about a Venn diagram. So the diagram below has 4 regions. 3 of the regions are within the circles, and 1 region is outside the circles and inside the rectangle. So let's take a look at those 4 regions right now. So this would be one region in here. Another region would be here, this sort of football looking region, and this would be a third region. And then the 4th region would be outside the circles but inside the rectangle, so over here somewhere. So we've got those 4 different regions. The circle on the left represents ways in which your instructor can increase student success. The circle on the right represents ways in which you can increase your own success. The region where the circles overlap represents ways both you and your instructor can increase student success. And the area outside the circles and inside the rectangle represent ways to increase student success that are not actions of the instructor or the student. List at least 3 components for each of the 4 regions. So I'm going to have you guys do this on your own, but I'm going to, just go through one thing for each region that I could think of, and then have you add some more stuff in here. So let's see. Something that I could do to help you with your success, hopefully, is actually making these videos. I think that these videos might be helpful. That's something that I'm going to do. Instructional videos, not necessarily something that you would do, right? What's something that we could both do that would increase the chances of your success? I'd say communicate. That's not something that's just one or the other, right? Let's see, communicate. I can't talk and spell at the same time. Okay, there we go. So notice how the word communicate is inside the instructor circle, and it's also inside the student circle. So since it's in this overlapping region in the middle, it applies to both the instructor and the student. All right, what's something that you can do to increase your success that isn't something that I need to do? Let's say do homework. Do the assigned work. And you could write this as a sentence if you want. What's something that would increase your success that is not something either of us would do? Well, I mean, I think having good technology at school is important because I use it. Maybe that's something for me. Well, Canvas, thinking about technology, we're going to use Canvas to communicate with each other, and there are people that keep Canvas running and keep it working. Not me or you, but it definitely increases your success when Canvas is working properly. So that's sort of the idea, all right? So I want you to go ahead and finish this. You can pause the video now and do it, or come back to it. But I want you to go ahead and complete at least 3 components for each of the 4 regions. So we've done 1 component for each of the 4 regions. So now we're going to use a Venn diagram to do a little more of a mathy thing. As I said earlier, the rectangle represents the universal set. So the universal set is the reflection of its name. It stands for the set of all objects under consideration. So back here, objects under consideration were like actions. And I know the word canvas isn't really an action. I should probably say something like keep canvas running, or something like that. Okay, that's the action. Keep it running smoothly. So in the next example we're going to do, we're going to be using maybe some of these sets as the universal set. We're going to be using numbers instead of actions. So here's 3 sets of numbers that we'll use quite often. The first set is the natural numbers. Those start at 1 and go up. They're called the counting numbers. They don't include fractions or decimal numbers. The whole numbers are pretty much the same as the natural numbers, except it includes the number 0. And the integers are the positive and negative whole numbers. Okay, so positives and negatives and also 0. None of these sets include fractions like 3 1/2 or decimals like 87.5. Now these dot dot dots mean that it goes forever. So the number a million is a natural number. A million is a whole number. A million is an integer. And negative a million is also an integer. So the dot dot dots mean that it goes forever in that pattern. In this book, what you're going to find is words that are bold and italicized are vocabulary words that you need to know and understand. So this might be a good study tool as you're going along. If there's words that you think you need to study, maybe start making index cards of those words. So the next vocabulary word we have here is factor. An integer is a factor, so we're using the word integer here, so it could be any number from this set of integers, is a factor of 24 if it divides into 24 evenly. In other words, if 24 is divided by an integer and the result is another integer, without a remainder is what we mean, then both of those integers are factors of 24. List all the factors of 24. All right, so we're going to go through this together and start thinking about numbers that multiply to be 24 that are integers. And I'm going to show you a little way to kind of keep track of those numbers. So the first set of factors is 1 and 24, right? 1 and whatever number you're trying to get the factors for always go into that number. So what I like to do is list them, let's do it this way, 1 and 24 as pairs. Now, it could be positive or negative 24 as well because we're doing integers here, but I'm just going to list them without the positive and negative right now. So then what I like to do is go the next number up from 1, which would be 2. Does 2 go into 24? Yes, it does, right? So 2 and what? 2 and 12. So now I know the only numbers that I have to worry about for factors are anything between 2 and 12. So see, these numbers are getting closer together. Let's go up 1 from 2 would be 3. Does 3 go into 24? Yeah, it does. How many times? 8, right? So now I only have to worry about numbers between 3 and 8. I don't have that many to check anymore. What's the next number up from 3? Well, that would be 4. So 4 times what is 24? That would be 6. So 4 and 6 are a pair. Now the only number I have to check is 5, and 5 doesn't go into 24. Another way to write that out, so these are all the factors of 24, all right? So another way to write that out would be in a string. So sometimes I do it this way. I go 1, let's put this, and 24. And then I go 2 and 12, 3 and 8, 4 and 6. And then there's nothing between, 5 doesn't go in there, so there's your list of factors. That really helps do it in an organized way, find the factors in an organized way so you know you're not missing any of the factors. So now technically it could be positive or negative of any of these numbers, so we can write plus or minus next to these. That means positive or negative. Positive or negative 3, positive or negative 4, positive or negative 8. So one of the prereqs of this class is knowing your positives and negatives. Knowing that negative times a negative is a positive. If that's something you need to work on, then make sure you review those. So that's why negative 3 is a factor of 24, because 24 divided by negative 3 results in another integer, which would be negative 8. All right, so now we're going to do a Venn diagram problem about factors. So in the Venn diagram below, define the universal set as the set of all whole numbers. Okay, so this is important now. The universal set is all the whole numbers. That means we can't have any negatives. So here's the whole numbers, 0 counting upwards. The circle on the left represents all the factors of 24, and the circle on the right represents the factors of 36. Let's write that down. I always think that's a good idea. So this is going to be factors of 24. And this is going to be factors of 36 in this circle. What does the region in which the circles overlap represent? Now, one of the things in this video that I want you to always do is not wait for me to answer the question. And sometimes I'll even say pause the video and write down your answer. And I encourage you to do that. If you are not doing that, if you're skipping that part and just waiting for me to tell you the answer, it's going to catch up with you and you're really not learning at that point. So it's important to do that. What does the region in which the circles overlap represent? You got it? What would be this region right here? So if a number goes in this region, if I put some number here, that number, this is the region where they overlap, this sort of football shaped looking thing here. If I put some number and write it inside this area here, this region is inside both of these circles. So that would mean whatever number I put in here would have to be a factor of both 24 and 36. Can you think of a number that would be a factor of both 24 and 36? I bet you can. I bet you can think of a few of them. I'm going to have you guys complete this on your own, but let's put one of them in here. How about 1, right? So you're going to have to list out the factors of 36, like we did with 24, to really make this easy for yourself. Here we did the factors of 24. So you do the same thing with 36, and then you'll be able to complete the Venn diagram. But we know that there's going to be the number 1 is going to go in here. That's going to be a factor of both 24 and 36. So what does the region in which the circles overlap represent? Whole numbers, because remember the universal set was whole numbers. Whole numbers that are factors of both 24 and 36. Now, if I haven't made it clear already, you are writing down everything I'm writing down, and you're going to upload these notes, as well as you're going to write down stuff that, you know, we didn't get to, like the activity above where you're going to fill out more stuff for increasing student success, okay? What does the region outside the circles and inside the rectangle represent? Outside the circles and inside the rectangle. That's going to be this region out here. You know, like here, outside the circles and inside the rectangle. What would that region represent? That's going to be whole numbers, because the universal set is whole numbers. That's going to be whole numbers that are not factors of 24 or 36. Some whole number that's not a factor of 24 and not a factor of 36. Can you think of one? I can think of some. How about 7? That'd be a good one. 7 is not a factor of 36 and it's not a factor of 24, but it is a whole number. The universal set was the whole number. So I don't have to worry about I don't have to worry about the negatives here because the universal set was the whole numbers. So part C says to complete the Venn diagram. So what I want you to do is I want you to list out all the possible values that go here, and all the possible values that go here, and all the possible values that go in this region. Now you can't list all the possible values that go in the pink region out here, but list like 4 values. So we already have 7. So list 4 more values that would go into there. Whole numbers that are not factors of 24 or 36. All right, let's look at the next one. In this Venn diagram, the universal set is the set of all real numbers. Now, we haven't really defined what real numbers are. Let's take a second and do that. Basically, real numbers are any number that you guys know of. There are some numbers called imaginary numbers, but we're not going to talk about that. Yes, I'm not making that up. So real numbers are any number that you know. So it's all the integers, okay, all those integers that we talked about earlier. Plus it's all the fractions, all the decimals. Basically, if you had a number line, any number that you can find on a number line is a real number. All right, not just the labeled ones, right? So like here is a half. That's a real number. Here is 1.7285 or something. I'm just making up stuff. 1.7285. That's a real number. Any fraction, any decimal, as well as numbers like pi. Okay, or square root of 2. Those are real numbers. And you could find the decimal approximations for these using your calculator, or maybe you know that pi is 3.14. Okay, so that's our universal set. So inside this rectangle could be any real number. The circle on the left represents all fractions with a value between negative 0.75 and 0. Interesting. So fractions that have to be between negative 0.75 and 0. Now, since we're doing fractions, we could write negative 0.75 as a fraction. What's negative 0.75 as a fraction? You got it? This would be negative 3/4 and 0. So maybe a way to think about this is to use a number line and say here's 0, here's negative 1, here's negative 3/4 or negative 0.75. So basically any number that lives in here on the number line between 0 and negative 3.4 that you could write as a fraction. Okay, so those would be all the fractions between negative 3/4 and 0. The circle on the right represents all fractions that can be simplified or reduced. Any fraction that can be reduced. It's kind of hard to write sideways here. All right, there we go. So for example, I'll just write some out here. Let's say 10/15. That can be reduced. So that is a fraction that can be reduced, or negative 10/15. That can be reduced. A number like 1/7, that can't be reduced. That's already reduced, so we wouldn't say that. It could be an improper fraction like 425/30. That can be reduced because they both have a factor of 5. So it says list at least 5 numbers for each of the 4 regions. Why don't you pause the video and try this one, okay? Pause the video and see if you can come up with at least one number, before you restart it, that would go in each of these 4 regions, right? Region 1, that's kind of confusing. Let's just highlight them. So we have this region, the outside region here, we have the overlapping region, and then we have this region over here. So let's just think about what these represent. So the pink is going to be, this pink region is going to be any number that's not between negative 3/4 and 0, and any fraction that cannot be reduced. It has to meet both those criteria. The blue region is going to be a fraction between negative 3/4 and 0 that cannot be reduced. The yellow region has to meet both these criteria. So it has to be between negative 3/4 and 0, and it can be simplified. The purple region has to meet this criteria, but not the other one. So the purple region has to be a fraction that can be reduced, but not between negative 3/4 and 0. Okay, all right, pause the video, see if you can do that. Restart the video when you think you've got some values that work. All right, let's try a couple here. Now there are infinitely many possibilities, so I'm just gonna pick some and see if they make sense to you. So let's start with this region right here. Some fraction between negative 3/4 and 0 that cannot be reduced. So some fraction in here that cannot be reduced. Well, shoot, I think even like negative 1/4 would work, right? Or negative 1/2. That cannot be reduced, so that would work. So it's not inside, negative 1/4 is not inside this circle, because this circle is only for fractions that can be reduced. So that's why it's outside that circle. Okay, let's do inside here. So I need to pick a fraction between negative 3/4 and 0 that can be reduced. So why don't I just do the negative 1/4 still, but turn it into something that can be reduced, like negative 2/8. So negative 2/8 is between negative 3/4 and 0, and it can be reduced. So it's inside both of those circles. All right? Let's try this region over here. So some fraction that can be reduced that's not between negative 3/4 and 0. Well, any of these I wrote over here would work, like 10/15. That can be reduced, but it's not between negative 3/4 and 0. And how about this region out here, outside here? So some fraction that's not between negative 3/4 and 0 and cannot be reduced. Well, how about, so we need some number out that cannot be reduced. You got something? Maybe something out even over here, like a half, right? That would work. A half is, let's make sure it does not meet both these criteria. So it's not a fraction between negative 3/4 and 0, and it's not a fraction that can be reduced. So that would work. All right, so I want you to list at least 5 numbers for each of the 4 regions. So you go ahead and finish that. And that will complete activity 2.